Hello everyone, my name is Suman from Uplatz. So the course we are discussing with the PySpark. In the PySpark we have been completed modules related to modules, or we can say components, especially in a entire Spark framework and architecture. So we have been done with Spark RDDs, Spark data frames, and SQL data frames. And not only just a simple information, like we have been taken various sort of operations like data cleaning section, we have been gone, data manipulations, data analysis, and data visualizations. So these are the further we learn so many things. Like what we learned in the early in the data science in the pandas data frame, right? So the data frame is same, but the environment is different. Like pandas data frame is different because that is better for this small scale, medium scale data, whereas Spark data frame is high efficient for large scale systems. Okay, so that is the things, and PySpark related filtering is different. PySpark related, like we have been gone through creation of custom data, like including JSON mapping and grouping and separating, and so many things we have been done clearly. Now, today's sessions, we started with another component is called MLlib. So when it comes to MLlib, now we have to make sure to go back our machine learning concepts. So let's try to understand the basic parts of machine learning, and we'll slowly further move ahead with the MLlib module in Spark. Okay, what is machine learning? Like what we learned so far is understanding the data, describing the data, and analyzing the data and visualizing the data. These are the things we covered. I mean, broadly we can speak if you want to break down into the completed topics. Okay. So these are fine enough to know it what historical data has, and we can able to make sure to provide. We can able to understand ML part. I mean, sorry, profiling part and exploration part, data analysis and data cleaning. Those are the things we covered up. Now, machine learning is what? Machine learning is, we can say, in data science, in big data, in even cloud components. And if you join everything, like in a entire AI field, so machine learning is a kind of branch, okay, sub branch, or we can say branch or support. Okay, we take a Venn diagram, you can easily understand. This is one kind of circle, which is diagramly internal part of AI. Let's move ahead with machine learning. Machine learning is nothing but what? Simply take historical data or take available data, can be able to predict based on the available data for the future. Okay, in a simple term, but in a real life world term, like presently, I mean, in this kind of generation, almost every person is using machine learning. General person, I'm telling, not just like, who is a person technical, who is a software industry, or who is other person. Every person normally using machine learning in general, their daily life. Let's make it a simple concept. For example, you can take anything like Amazon, Flipkart, or something. Okay, you are buying a product in a certain time early. Let's make it a Google search. Google search itself is machine learning. You are searching fine, but what you are searching is backend. It is storing as a history. Okay, and it's storing as a history, and that history will be is data which is available for the Google to provide what you need or what you make if you do. with the get while searching. Now, if you search it, I mean, let's go back to Google, just a simple example. If you search anything related to just one word, okay, one word in the sense like, let's take it as a prominent word name. Like you can take into like Joe Biden or something like that, or Narendra Modi, something. Now, if you search it, it's giving us a first page, second page, third page, and goes on millions, billions of pages it's giving in the internet. What are those pages? Those are pages are nothing but websites. Those are pages are nothing but getting the data from the internet world, entire world. But orally, it's showing as a first. Most of the people looking at the first page, and in the first page, mostly first link, second link, third link, something like that. So mostly what top three or top five. Even sometimes we can go to second or mostly at most last third page in rare cases. Now we can't go to millions of pages, right? Definitely. But how it is segregating. It's a kind of working on the back end, kind of the data which is storing internally, and it's categorizing the data based on the views. Most of the views will be comes first, and latest news. Most of the news is different. Latest news is different. So latest news may be couple of seconds back, couple of minutes back, a couple of hours back, or maybe one day back, 1 week back. So these are live related to the data which stored. Okay. So we are just focusing on a point and click. That's only we know it. But in the backend, algorithms are doing that kind of entire thing is going on machine learning. So that is one sort of example. Now let's take it into the e-commerce sector. Now let's take into e-commerce sector. Like Amazon, you can take Flipkart, you can take Swiggy, you can take, or you can take Zomato or anything. Now question comes to here is you are searching a product in Amazon. So that product might be anything like TV or mobile, or it might be like infrastructure in your home or something like that, or dress like something like trouser or dress. Now orally you are searching, but the searching is stored in the internally the data. Now it will able to give it a better better product rather than early. Even it's also providing relevant product. So that is also machine learning. I mean, we can use it. Okay. Now we are using smartphones, right? So so many times we are getting like reminder calls or something like those are things. Now there are two concepts are there. Like machine learning is there, one concept, but there is a hard code, thing is also there. Like we can say formula kind of thing. So like if you give it a formula like a plus b whole square, okay, it will provide a formula a square plus b square plus 2ab, right? That's very simple. Now, if you provide any number plus some number, so it will provide that kind of result whole square. Okay. So 9 plus 9 whole square, I mean 9 plus 9 18. 18 whole square is how much you will get that result or totally. But that is the different. Like we are getting formula and we're writing the formula and we're getting that's fine. But machine learning is not more than that one. Okay. So based on historical data, it has to be predict and understand, and it has to be improve itself. Okay. So that is what machine learning in general. Okay. So one thing is it can able to predict like that prediction might be we didn't estimate sometimes, or sometimes we can estimate, but data is more, right? So we can't go to each and every rows, each and every record, or we can't go to each and every field or columns or variables. Now orally we have to make sure to provide the prediction kind of thing. So we have to look it forward. Okay. So that is one thing. And in Spark related context, we have to use it this MLlib concept, MLlib machine learning library. In short, we can say MLlib. Okay. So here MLlib algorithm takes PySpark. So to hands-on experience is just to understand here. These are the algorithms. Like before algorithms, let's make sure to understand there are two concepts are there. Okay. So first thing, let's try it here. Let's say this is true, we'll make it into supervised and unsupervised machine learning. Unsupervised machine learning. Let's find out this important thing, then move forward. So what is supervised machine learning? Supervised machine learning is nothing but you have data or we have data, and along with the data, we do have input and output is also there. Both are there. Like take it a simple formula, but you know input and you know output, early data. Now we are questioning by giving input, what is the output we are getting? So that thing is called supervised machine learning. Okay. Under supervised machine learning, we do have algorithms are there. Like classification is there, regression is there. Okay. Especially supervised linear regression. Okay. Now when it comes to unsupervised machine learning, supervised machine learning, we do have classification and regression. These are the two concepts. Unsupervised machine learning, we have three: dimensionality reduction, so and other thing like clustering, and those things will be comes under unsupervised machine learning. Okay. Now let's focus on the supervised machine learning. For example, linear regression. So linear regression is what? First of all, regression we have to understand. Regression is nothing but, so it will follow a kind of concept like y equal to mx plus c. Y equal to mx plus c. This concept. This concept is also called slope and intercept formula. Okay. So what is slope and intercept formula? Like this is called slope. M is nothing but slope. C is called y intercept, and y is called output. Now x is called input. So if a person provided x, you have to get the output as that. Okay. So one thing. Second thing is the linear. Why we are making as linear? Because these values will be stored as a line oriented, linear only. Linear a kind of relationships. Relationship is important. So now the relationship between x and y is a linear. Okay. So you can take this x and this y. So these two concepts will be having like relationship between x and y should be the linear way. So like if slightly x goes on increasing, y is also increasing accordingly. Okay. Now even that is also different aspects are there, whether it is a positive or negative. If slightly increasing, slightly decreasing or something, increasing or x increasing, y is also increasing. That is also one aspect we can say. But what is m in that cases? M is called slope. So what is the change in dy by dx? Corresponding how x is changing, how much y changing. So that distance, the dy by dx is called slope. C is called y-intercept, where that line touches y-axis in general. So that these concepts are called linear regression formulas. Now, if your data has linear relationships, then we can apply linear regression. Now, in real general life, linear regressions are lot in a regular way. For example, you can take simple example like height versus weight. It has certain, age versus height. So if you typically take it maybe 0 years or 1 year too, maybe 15 or 16 or 17, 18. During that situation, or 21, it might be, not familiar, but at that age, till that age, person will be height will be grows. But how height grows is important based on the age increasing. So while increasing the age, obviously the height is also a person increased. Okay. So that concept is called linear regression. Why? Because age slightly increasing, accordingly, the height of the person is also increased. So these relationships are called linear regression. Okay. Now question comes to here is the for example, I do have data is there, some person's ages are there, some person's heights also there. Maybe first year this is the age, maybe third year, maybe sixth year, maybe 17th year, or maybe 21 year. This is the age and this is the height. Now then question comes to here is, if I ask it any person which have just age, now we don't have height, but can you able to tell that height? At least not not 100% as it is, a nearby value or maybe a predicted value. So that's also important for the. The question comes here is that age is presented in our data is not. One thing is important. Is that age is presented in our, historical data or not? One thing. Second thing is, can I say same age which a person is requesting? Should I say that the age is already available in my data? Should I tell that as it is a height? The answer is no. Why? Because maybe you can take a 15 years person age might be like 4 feet or something. Now they say 15 will be 4 feet. The answer is no, because some person may be height low, some person may be height, even age is also same, even months also same, even same day they born, same time also they born, but overall height will be changed. Okay, so because of genes, because of geographical locations, because of the person who is doing any kind of like physical exercise or something, everything is different. Okay, it's not like we can't take only age, but let's general assumptions we are taking. In that situations, now machine learning has to be provided. Okay, now person is that age is might be presented in our data, or it might be not presented. Even though not presented, machine learning has to be give the height. Okay, for example, person is asking something like 16 years age, 16 years some 6 months or something, but that age is not is there, but machine learning has to be give how much, how it is giving, that's important. It's giving, okay, but how it's giving is important. It follows this kind of technique called linear regression. It follows statistical concept called slope and intercept formula. Okay, so based on that, it will segregate and it will give it that kind of prediction. Now take it an other similar example, like relationship between is linear. Second thing is regression, that is called line. That line is called regression line. So that is why it is called linear regression. Now slope is important for us. Slope is better to know it. From the slope, once a provided person is provided x value, let's consider this x as age, simple, and this y is what? Height. But this m and c is comes from the these are called coefficients. So this m and c is called generally In general statistical terminology, we can say coefficients. So those comes from the algorithm. Okay, so those comes from the algorithm, and those given algorithm based on the data which have, okay, it changes accordingly. It changes as per. For example, you can take simple one example called China. Okay, one example called China related height and age. Now take it another country, maybe you can take West Indies or something, like height will be more a person's. But can I apply, same concept related to, the concept? So the answer is other variable will be affected, maybe geography. So maybe you can take maybe different concept variables. One is multiple variables is there, one is single variable is also there. Maybe you can take just age only and height only. That is called simple linear regression. Why? Because we do have independent variable, which I explained earlier. Dependent variables are there, independent variables are there. Dependent variable is nothing but height. Independent variable in the sense age, because we are providing age now, so that is independent. And height is dependent on age. Okay, so while age is increasing slightly, like height is also increasing. So that is called dependent. This is called independent. Now, question comes to here is, based on the available data, it has to be given the height of the person, right? So these concepts are called linear regression. Okay. Now, logistic regression is also there, decision tree is also there, and but here, here we can see logistic regression. Okay, and this is called decision trees. I'm just taking sample right now to make sure to understand very basics. So I have take simple data and a simple small data to understand, but you can apply this data relevant to large data anyway. Since we are using standalone single machine, so it's better to take, it's better, not only better, it's like it can manageable data. Okay. But when you go to company, like when you have large amount of data, the same things will apply. Only clustered it different, and the data distributed into various clusters is different compared with local and standalone. And computation is also different. Here computation is in single machine, definitely sequential processing is going, but whereas in cluster mode, it will go to parallel mode. The parallel kind of operations. I mean, computation is also parallel. Distribution is also data distributed. I mean, data splitted into multiple clusters. Okay. So that is the advantages related to big data handling, which I explained earlier. Now, I just want to take it such kind of examples. I want to explain this related concepts to make sure to understand, so that we will go further, and we'll make sure to know it. Now, different values. Okay, different kind of techniques. So Spark MLlib is, which is first focus of our a component in our Spark architecture. Second thing is scalable machine learning library. It's not like uh, normal ML library like which we are using rarely. Okay, so scikit-learn, right? So that is scikit-learn and related. And similar way, machine learning library which is scalable, which comes from the Apache Spark. Okay, but here I want to take up some practical examples and couple of data sets which we created, not just like taking from the external sources like already available data, but here newly generated data I have taken to make sure to understand for you. So I have taken some Indian, maybe you can take anything, a contextual data we have taken, and to illustration purpose only, but various algorithms. Okay. So like I explained, these are the fundamental ML algorithms like linear and logistic regression, decision trees, and clustering. Okay. So here I have provided some data sets. You can see the data sets here. First thing is it is providing CSV file, right? So this is house pricing, house pricing Indian cities, right? So what is the information which holds? So you can see here house price Indian related. What we look at generally city, city and the house area in square feet in general. And this is related to number of bedrooms in that for that house. And this age of the property maybe how many years? Maybe 10 years or 8 years. So we can take up that. And price I am giving in a lakhs. For example, this is 150 lakhs in Mumbai. When it comes to Delhi, 200 lakhs. When comes to Hyderabad, 130 lakhs. And Bangalore, 180. Obviously, Bangalore is, we know it is a high-tech kind of, thing. So definitely it has high. But even Delhi is also more metropolitan, right? So Mumbai. So we can look at here compare with. And Chennai is even 120. Now, question comes to here, this is simple data, right? So we do have simple 1, 2, 3, 4, 5 variables are there. So 5 variables and the name of the city and how much area square foot that, in that city, the house which has or which holds and the number of bedrooms because this is also important for price. Okay. You can see in regular if you go to walking or maybe if you go to street or anywhere, so they will give it a single single bedroom flat this much cost and double bedroom flat this much cost. Okay. So maybe family members count is more, they will take up more such kind of related flats, right? So in that way you can think of in that assumption you can think of it. Now age of property is also important. Yes. Why? Because so let's take it in old kind of old kind of age kind of houses. So that might be less in certain cases. Why? Because of material they used early compare with material later in the next newly made it material is different compared with. So that is also important, but overall price is the concept. Now second concept is purchase, customer purchases in retail store. Now this is also same way like but understanding the in a e-commerce retail kind of style, a module or domain. Customer ID, a person age, their income in lakhs. For example, this person age is 25, 4 lakhs he got it. I mean, he is earning. Number of transactions, how he made, and maybe purchases related to about 10,000, and he is the loyal customer or not. Okay. So that is related to loyal customer is related to the retail store is giving. For example, we are the customer, we can't go to every store and we are telling loyal customer. Right? Obviously, the e-commerce retail sector, retail company has to be give for us. Even though they didn't give it us, but secretly they will maintain. Okay, they will maintain who is the loyal and who is the not loyal. Okay, for example, you can take simple example. For example, this person age is 25, 4 lakhs he is earning. Find transactions he made it, and about 10 code just one only, one transaction on about 10K. But if you look at here, about 10K is 7. So he is maybe because of this thing, he might be loyal customer. Obviously, in that case, okay. Now, maybe 2 because of 2 or because of 10, it might be yes. Okay, 10 is more, right? So 30, 10 and all those things. He is earning more income as too. his age is also more. Now 29, similar way you can go. The orally we can say yes or no. This is called not like number, like whatever we early have been known with price. Price is different. Price is number. Price is a real number, especially number, but in a statistical way, in a mathematical way, we can say real number, okay, which contains a number. But in these cases, loyal customer is not a number, but it is a categorical data. Okay, so yes or no, it's a categorical data. Now, categorical data prediction is different compared with the numerical data prediction is different. So that's where we are using regression kind of thing, but this where we are using classification kind of thing. So that's why supervised machine learning comes into two parts, regression and classification. But algorithm name is linear regression, that is algorithm. But a categorization, we can say in the way of types, you can say regression and classification. Okay, so that is the one thing we have to know it in the first cases. And these are the data. Now question comes to here is we are using same way. First, linear regression we can apply on top of housing prices data. Okay, so linear regression I am going, and house pricing we want to look at. Okay, so for this I just want to take up, this is a simple example for regression task. This would be this this house price is a basic thing, we have to know it to predict house prices based on features. Based on features what? Based on features like area, number of bedrooms, and property, their proper age. Okay, so area is also square feet, right? So that is also one aspect of feature. Second thing is rooms, bedrooms especially, and property age. Now customer purchase, retail store is different. Like this data will explain classification, we can use it, clustering also we can use it. Okay, why? Because classification is nothing but we do have input output is there, and classifying the things into loyal or not. Okay, so predicting, you will say predicting customer loyalty, and not only that one, segmenting customers based on the features, like it might be age, income, transactions history, whatever transaction history we have. Based on that, or income related payment, how much salary he is getting, and person age. Once you have these features, these kind of variables, then we can say whether the person is a loyalty customer or not. Okay, segment. It's a kind of segmentation. So the kind of segmentation usually not only real estate, we can use customer segmentation in every almost all the domains, all the relevant domains. Okay. Now next portion is hands-on perspective. What we have to look at MLlib code, right? So each algorithm in our PySpark includes what? First, you have to load and prepare the data. But our data is very clean, which I have taken, but right now, but the data cleaning, which I explained early, data visualizations, which I explained early, exploration, which I explained early, that is a part to get the proper data cleaning. But load and prepare the data, then define which features and labels. Then we have to train the ML model, whatever the model we want to apply on top of it. Then evaluate the performance of the model, like on what basis you have to test this algorithm is better. That is called evaluation. For example, you can take student marks are there. Okay, person is giving the marks, but there is evaluation metric is there. No? So 35 out of the 100, 35 is nothing but pass. That is called evaluation. Otherwise, now everybody is getting some marks, right? So we can't go to Every person, for example, one person, one mark is also mark, 99 is also mark. But there should be some mechanism which has to be segregate, and who is eligible or who is not eligible, who is pass category, or maybe not, still he is trying, maybe supplementary or something like that. Okay, so these are the nothing but values. Now finally you have to get the insights, you have to get the predictions, and we have to get the results. Okay, so in regression we will use evaluation metrics, like mostly evaluation metrics are nothing but they are using different things. Like regression we are using mean squared error, and also there is root mean square error. Okay, mean square error and root mean square. In classification we will use accuracy and F1 score. Those are the things. In clustering we can use characteristics like each of the cluster, generated cluster. It's not like giving, but it's a generated cluster. Okay, now this is the main thing we have to know it first. And second thing is, so the here that algorithm can be mostly used. I mean, here we have taken a kind of concepts like real world scenario, and predicting property prices. Maybe you can say property prices across in cities. Okay. Second thing is identifying loyal customers for marketing campaign. Maybe marketing in retail business. Okay, so that is one thing. Or maybe segmenting customers into groups for different marketing strategies. Different marketing strategies. So segmenting customers into groups for different marketing kind of uh, like segments we have to apply. Okay. So these are the things. Even further we can able to look at, but let's make sure to understand here. So the concept will explain clearly, but so you have to move ahead with the steps and understand the concept and the steps regarding first loading and preparing the data. Since our data which have the concept here, PySpark data frame, right? So these data sets, whatever the features are there, that is, and target variable also we have to know it, and their metrics also we have to know it, and we have to prepare the features, like we have to suitable format for training data for any kind of algorithm. Feature engineering we can do it. Similarly, we can move ahead with assembling features and labeling. These are the second, or maybe after loading. Then we have to train the model. What is the perfect algorithm we have to make sure to initiate? Like we can say train the model, we can say fitting the model, almost the same, similar. Then we have to go for evaluations. Finally, we have to get the insights. Okay, these are the general steps. Okay. Now let's move ahead here for coding point of view, and let's make sure to understand here. I think let's make it into split this data. Okay, let's make it this value window remove. 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 Okay, let's try it here. I think we have to copy paste. I think this will be okay. We will do that. There is some mistake is there. Okay. So in these cases, what we have done, we are just we are initiating the Spark session, and in PySpark like ML library, we are just initiate ML feature, vector assembler is there, and in PySpark ML regression, linear regression is there. Okay. In scikit-learn, what we have been taken in the early scikit-learn cases, right? A linear regression we have taken, right? So similar concept here. But let's move ahead with the data set name, housing prices dot CSV, right? Housing prices dot CSV. Okay. Let's look at here data, and we can just show. Let's just show. Let's make it. Okay, we got it. It's late because some time. Okay, so city is there, area. Oh, we got it, right? Clearly information. Now, next question is second step is we have to make sure to provide kind of prepare the data. Okay, so for that I have taken here. Let's split the data and provide here, right? Now, what I'm taking here, assembler, we are taking vector assembler, like what we loaded module, and here giving input columns, area and this thing, but except output column, we are giving features. Okay. Now that features we are telling that price underscore lakhs is the last column. Okay. And just to store it here. Now assembler contains input data, obviously, and this will contains output data, right? So let's make sure to convert this to code and just execute it here. Now it is done. Now the next question comes to here is split the model. So let's remove this value and remove this value and just cut it and make it into something like change it into Y. Now train the model. So here I'm taking LR, linear regression, and here we are giving feature columns features, and label columns we are giving into price underscore lakhs, and we have to fit the model. Okay, so fit the model of taking this value. Okay, now a model is we got it, but let's ask it a prediction. Now take it a prediction here the same way, or you can take it. I mean, I just give it a your this notebook is better. Let's take this value. Just come out to here and change it y. Now, okay. up this. Okay. I can see we got this file. Okay. What is we got it here. Now these are the features which contains the 1200 first, 2.0 and 10.0, right? So if you look at here, 1200, 2.0 and 10.0. That actually price is 150 lakh. But our algorithm is algorithm is in 142 lakh. Okay. So it might be nearby. Okay. Because this is very small data. Of course, you might say, sir, we didn't get 149 or 150 or 151, right? 150. So because of small data, it's providing that kind of information. But when you have large train of data, like definitely it will provide better accuracy, nearby accuracy. But to make sure to understand, I'm giving this simple example to understand yourself. And here, this is the data which have in our data for this house, which contains 1200 square feet and 2 bedroom. And third thing is 10 kind of, like 10 is what? Age of 10 years. Okay. For this data, we have 150, but algorithm is providing 142 nearby. So 200, we got 189, 130, 138, 180, 190. So 120, 180, it might be nearby. Okay. So these are called predictions. Okay. Now the value we are getting this from the model while predicting. This is our data which have in our data output, and this is called prediction. We are comparing this sign versus this. Okay. Now the same way here, what we'll do, from the insight, what we'll tell. I mean, I'm not going into more. Evaluation metrics and inside. I'm not going into in depth right now because just want to know what is input, what out in the initial cases. So we will further we'll look at into further kind of metrics, but just right now you can focus on the very main mandatory things we have to look at. Okay, main things we have to move ahead. So insights what we are getting in the for this simple plain small data. This model predicts house prices based on the square footage, bedroom count, and property age. Evaluate using RMSE to see the prediction accuracy. Okay. So let's move ahead with the decision tree. Same way, this value. So here I want to take it this value, or we'll take it this as this. Let's make it into logistic regression. K means clustering we have done, and I think logistic regression we didn't done. Okay, let's make it here. I just want to add it again. Let's split. Just select it here and change it to 1. Now here I am taking another kind of thing, customer purchases.csv. Now early cases what we have taken house prices, right? That is for regression. But this is for classification. So that is the reason we are taking customers related purchase. Okay. Now just make it here and just change it in the same way as we done early. Just change it and just combine. Oh, sorry, combine. Combine in the sense like change it. Now here defining the features and we defined. Now in the same way I have taken, but here income lakhs and number of transactions I have taken, except except the value which is loyal or not. The person is the loyal customer or not. Okay. So that is makes you to head. Now let's build the model. So create the model here. And for this, I have taken this value. So train the model here in the same way. Take it. Now model has been built. Now let's question for the prediction. The show is done. Done. Now to build the model. Now let's question for the prediction. Now you can see we got this value. Okay. So what is the value we got? It is important. For example, 00 indicate not loyal customer. I mean here machine learning will be not works for the categorical directed data. So we have to turn it has to be turned into numerical. So 00 indicate actually the person first will not loyal, right? I think 00 just move ahead here. Not loyal, no loyal. This is 00 and this is 1. Now let's consider how machine learning is giving predictions. Now, if you look at the data here, you can see 00 it's giving perfectly. Okay. 1 is also it's giving perfectly. Means this is a loyal customer. The algorithm is also saying loyal. This is also giving perfectly, and this is also giving perfectly. 1. This is also giving perfectly, right? So almost 100% this is true. Even though small data, it's giving 100% accuracy. But in general, real life, it's not get to 100% accuracy. But in the meanwhile, we can make sure to understand in that kind of stuff. Okay. So that is the concept. And here we got it insights related. So this values gives us the classifier helps to predict loyal customers based on the lot of variables. Of course, couple of variables: income, age, transactions, behavior, and evaluations can be done using accuracy and F1 score. So that we will move ahead and let's move ahead with the understanding later on. I just added that also. But here we do understand, okay? So we have been taken, I have to be taken two algorithms, regression and classification. These are the supervised machine learning. Now in the next session, we will move ahead with unsupervised machine learning and we will look at into some kind of maybe similar data or same data or more such kind of features. And we will try to understand further to take it unsupervised as to. Even supervised is also some algorithms also still there. It's not only linear regression is for regression and decision trees is only for classification. Logistic regression is there, random forest is there, support vector machine is there, k nearest neighbor is there. These are all set of algorithms. So that will move ahead, but understanding the data, understanding prediction is important for us first, and what we are giving, what algorithm is taking, and what it is predicting, how it is, how what is the result we are getting the predictions. So that's we have been completed today's sessions. Okay, today's session. Okay. So we started with very basics, like we started with the what is ML and what is machine learning, and what is how machine learning is differentiated with data science and I mean data analytics and all those data analysis. Then we started with PySpark related MLlib module, and we loaded the data, and we have taken two sample data sets. Like one is for real estate domain data, house price prediction. Second is for whether the customer is loyal or not based on the various features. Like you can take e-commerce sector or retail sector. Okay. So this is one concept for applying on the classification kind of algorithms. Okay. In a supervised only, same supervised, same supervised regression classifications. Regression, linear regression we have taken. Classification, we have taken decision trees right now because these are easy. And we didn't went further very internally. We have been not digging to total in depth, but we understood the data. I hope you got it to understand. Okay, what is machine learning, how it is differentiate, and what values we are getting is important for us. Okay, for this session. Okay. I'll just wind up this session for today's, and we'll move ahead with the next session, and we'll further look into a couple of algorithms regarding our MLlib, related to component of PySpark. Okay, so that's about the next session. Thank you very much, and thanks for watching all these sessions. And you can understand next session about remaining things.